So hello, everyone. Welcome to the session. So the first thing to note is this workshop is on my GitHub, and I'm sharing a link for it in the chat session. And this talk will basically just be an introduction to Scikit-Learn. We will not learn everything about the library. We'll learn about why we use Scikit-Learn versus other libraries, some advantages and disadvantages of Scikit-Learn as opposed to other tools and frameworks, as well as how to tune a model and how to appropriately format data so that your model is acceptable or your data is acceptable for a machine learning model. Because models are great, but if you can't get your data into a model, the model can't do anything. So and the materials for the talk are posted by Diane and me in the session. So with that said, I would now like you to either clone this, or you can download this as a zip file. Either will work just as fine. So if I did it by a zip file, I would just take the folder, move it to my desktop, and unzip it. Alternatively, I could git clone. So what I'm doing right now is I'm changing directories to my desktop, and then I'm just cloning repository. Everyone on the same page? Oh, and how do we see that chat? Diane or Graham, could you help out with that? So from here, I'm going to cd into my directory, DSGO, Introduction to Machine Learning. And for those of you that aren't super familiar with command line, terminal, if you're on a Mac, essentially all it is when I cd into something is I go inside this folder on my desktop. And what I first want to start with is an introduction PowerPoint. So for you, you can use the introduction PDF if you want to have PowerPoint. And for me, I'm going to use the PowerPoint file. Oh. So the title of this talk is Machine Learning with Scikit-Learn. So about me, before we start this talk, I just want to get you an idea of who I am, what I've done, so you can understand where I'm coming from when I talk about the advantages and disadvantages of the Scikit-Learn library. So before I started teaching a lot, I worked somewhere called Scripps Research Translational Institute, and a lot of what I dealt with was data science applied to wearable devices. So if you ever worn a Fitbit, Apple Watch, or similar device, especially a Fitbit, I worked a lot with that sort of data. A lot of it was predicting sleep or exercise based on characteristics of a user. Typically, it's on activity profiles or sleep, that sort of thing. I also teach at Stanford Continuing Studies, where I teach machine learning, and I have a couple LinkedIn Learning classes. So there's a few things I would advise you know before this talk, as it will make it a lot easier to understand what we're doing. So Python strings, integers and floats, conditionals and booleans, if, else, and elif, for loops, lists, tuples, and basically basic Python data structures. While I'd love to cover everything inside of a 2-hour window, essentially, it's not strictly possible to cover all of the introduction to Python, as well as the pandas and matpot libraries before getting to Scikit-Learn. I will talk about pandas and matplotlib quite a bit, as a lot of machine learning is getting your data in a nice format, as well as visualizing your data, as well as the output of your model. So as far as what is machine learning, Arthur Samuel was a major pioneer of machine learning. And he said that machine learning is a field of study that gives computers the ability to learn from data without being explicitly programmed. So while we could make rule-based, in some sense, algorithms, where we just have a question and divide data until we get to some prediction or some conclusion, it's not the smartest, as having computers learn from data without us telling them what to do is just a lot more efficient and a lot more maintainable. So the learning part of machine learning comes in when we give models tunable parameters that can be adapted to observe data. In this way, the program can be considered to be learning from the data. And this is a quote by Jake van der Plas. He's the author of the Python Data Science Handbook. And one thing I want to mention about the learning part of machine learning, and especially in this talk, is we'll be talking about hyperparameters versus parameters. And it's a real essential part of machine learning to be able to tune a model to get the best possible performance from a machine learning model. As if you don't tune a model, oftentimes it's not as great as if you put effort into making the model as best as it can be. And so once you train a model, you can use that model to predict and understand your data in a new way. So there are a couple different basic types of machine learning. There's supervised learning, where you learn the relationship between some measured features of the data and some target. And this can be a label or a value. So when your target, i.e. what you want to predict, is a label, it's considered a classification problem. And when your target is a continuous value, i.e. a home price, or stock market values, it's considered a regression problem. There's also something called unsupervised learning, which we're really not going to talk too much about today because of the time constraints. And that's when you model the measured features of data without some target or label or value. To make this a bit more clear, I'd like to show an image. So here's supervised learning about the type of data you should put into your model. So you have a features matrix where you have number of rows, number of columns, as well as a target vector, which is what you want to predict. So as I mentioned before, this could either be something continuous or categorical. If it's continuous, you most likely have a regression problem. If it's categorical, you have a classification problem. For classification, those can be things like predicting flower species or recognizing digits as something 0 through 9, very simple, or recognize that I'm a person or not. So for unsupervised learning, we don't have a target vector. We just want to understand our data better. There's a lot of different reasons why you want to use unsupervised learning, and some of it's kind of outside the context of this talk. But while talking is great, and I'll get to the actual programming in a second, I just want to talk about a little bit about why we use Scikit-Learn for machine learning. In Python, there are a lot of great libraries that allow us to efficiently clean and work with our data. And programming machine learning algorithms from scratch can take a very, very long time. And you're also more likely to make an error versus a group of people that have collectively worked together to make a library from scratch. They've tested it, they've made it a lot more foolproof than you just making an algorithm from scratch. So that's one advantage of Scikit-Learn. That's why you'd use a library in particular. And the reason why Scikit-Learn is really great is it gives you a really large amount of well-programmed algorithms. So this also means that there's a lot of great default values for a lot of machine learning algorithms, so that if you just use the model outside the box, so to speak, it'll work relatively well. Additionally, the syntax is really simple, as you'll see today. This talk will seem almost formulaic, where you import the model that you want to use, you make an instance name model, you fit it, and you predict it. So that syntax is very transferable to many different algorithms. So you can try out 5 or 10 different algorithms very quickly if you want to. And perhaps most importantly, Python is a lot of ways very much a library-based programming language. You can do a lot of different things with wonderful Python libraries. And Scikit-Learn plays really well with Python libraries such as NumPy, Pandas, and matplotlib. So when you read your data, you can do it with Pandas and NumPy, as well as when you explore your data, you can do it with Pandas and matplotlib to visualize different relationships and to transform your data in the case of NumPy and Pandas. And the final reason why you want to use Scikit-Learn is the library is really popular. So there's always going to be more Scikit-Learn tutorials. And that means that when you have a problem, as we'll see today, you can always get your questions answered more easily. So this talk is by far not the first Scikit-Learn talk. It will not be the last. And I've seen talks going into the early 2010s. So this is a very popular library. It's being used a ton, and I expect it'll be used a lot more in the future. And it's really, really important to emphasize that the fact that the library is popular means it's a lot easier to get help. There's less likely to be errors with the library itself. And when you get some sort of weird result, there are people on Stack Overflow that chances are have had your issue before. So you get your problem solved. So as far as why we're using Scikit-Learn in this talk, and the main reason is I want to teach machine learning, but the problem is if you just use different libraries, oftentimes it takes more time to get started. And so you don't really get to understand the different strengths and weaknesses of different libraries. In the process of learning about different machine learning algorithms, we'll learn concepts and reinforce concepts if you already know them, such as bias, variance, and overfitting. So with that, I'd like to get to programming. So does anyone have any questions so far that I can help? Okay. So from here, I'd like to talk just briefly about like getting set up with either Anaconda or Google Colab. So inside the repository that is posted in the chat, I have a setup document. It's a markdown file. And for this talk, you can either use Anaconda or Google Colab. So if you're using Google Colab, I don't have so much time to support everyone for Google Colab, but just let me know. We can always work something out between session 1 and session 2. But I really prefer to use Anaconda for this talk for a couple different reasons. So Anaconda is a Python distribution, and it contains a lot of the libraries that we use in this talk. So NumPy, Scikit-Learn, SciPy, and Pandas, to name a few. And the reason why I like this is it's pretty easy to install additional packages on your local computer if you already have Anaconda installed. And especially with machine learning, when you run into like larger data sets, it really helps to either run something locally or in the cloud. In the case of me, I have 16 gigabytes of RAM to work with on my computer. So I prefer this over Google Colab, where the default version gives you about a gigabyte of RAM, last I checked. And for a lot of tasks, that's just not a lot of compute power. So with any sort of tool, I always recommend looking at the weaknesses as well as the strengths, because a lot of us are biased for one tool versus another. So I love Anaconda. If you Google my name, I've written 1,000 tutorials on it, but it's not perfect. It's not a perfect tool, as none is. It takes more effort to get running than Colab, for example. With Colab, you can really easily just put a notebook and then open Google Colab. It's pretty simple. And the other issue is installation varies depending on your operating system. So, and Anaconda actually happens to be free. So one thing about giving a talk is that sometimes the people giving the talk don't proofread what they're doing. So, I'm just making a small change on my readme. And this happens all the time. So if you're curious about how to install Anaconda, if you want to follow along, I left a link here for if you have a Windows system. I wrote this tutorial a while back, but it goes through like why you'd want to use Anaconda, why it's useful, some issues, and some choices you have when you install it, as well as how to debug a couple of common issues. So that's the disadvantage of Anaconda, is just that you can have installation issues. And here's a tutorial on Mac that I wrote ages ago, but it still works fine. So you can also use Google Colab, but the only disadvantage of it really is that it's not owned by you. It's owned by Google, and it's free at the moment for a small amount of RAM, but it may not be in the future. Who knows? And if you want a bigger version of it, Google Colab is also now a product. And there's a introduction to Google Cloud if you're curious. And it really is as simple as running things in the browser. It's pretty fast. So with that being said, I'd like to open notebooks locally. Additionally, if anyone has any major issues, Diane, feel free to interrupt me. I'm always happy to go back and talk about things. So what I'll do now is I'm going to split my screen a little bit and just show you that I'm opening a Jupyter Notebook on my local computer. Okay. Yes. So one quick question, is it possible an idea about what percent of people use Python to solve data science problems versus other tools such as Tableau? I'll briefly answer this one because it's, So what I'm going to open, I'll get to that in a second, Rebecca, is while visualization tools are great like Tableau, if you're doing anything machine learning based, it really helps to use a bunch of libraries in Python, as Tableau is designed as a tool for visualization at the moment, but it's not fantastic for machine learning. Additionally, when you have larger data sets, it really helps to use Python as a tool. Additionally, there's a lot of Python wrappers for a lot of deep learning libraries if you get to that point, where the Python wrappers are amazing for deep learning. And as of this moment, Tableau does not have that functionality as clearly included. But visualization is a really, really important skill. If you can't explain how something works, then you have some issues, at least to stakeholders, which I'm happy to talk about later. So I'm opening a Jupyter Notebook inside the Data Science Go repo. And so from here, I'm going to open a notebook. And the first notebook I'll go over is formatting data for machine learning. I know this is not a fun topic, but in order to get data, Scikit-Learn expects you to have data in a nice format. So the goal of this notebook is to really just learn how Scikit-Learn expects data to be in. And additionally, how to convert your data into a format that Scikit-Learn will actually understand, accept, and not misunderstand. So as I mentioned in the earlier part of this talk, before we do any sort of machine learning model, we have to create a features matrix and a target vector in the case of supervised learning. So one thing to note here before we continue is that the features matrix is always two-dimensional. So you always have number of rows, number of columns. And often for the target vector, it's one-dimensional. And I'll show you how to deal with that sort of issue if it arises. So here are the rows going across a sample data frame. And this is on the Abelo data set, or Abalone. And we also have columns. And this is our entire data set. What we're going to do in this notebook is simply divide up our features matrix and our target vector. So rings will be our target vector in this case, at least in the next notebook. And our features matrix will be the rest of the columns here. So before we do anything, it's really important to load your libraries. So if we're using Scikit-Learn, we really need to be able to load it so we can use it. So I'm going to import Scikit-Learn because I'm using, well, actually, I'm not going to import Scikit-Learn here. I'll import pandas and matpot because we're just formatting data here. The data set is the Abalone data set. And the whole point of this data set from UCI is determining the age of an abalone can take quite a bit of time. And it'd be nice if there's a machine learning way to do this, because before it was really just like counting number of rings in the abalone. And it's not always clear. Some of them were more worn out by the ocean and a bunch of other stuff. So the first thing is to import the library or import the data set. This data set happens to be located on my GitHub inside a folder called tutorial data. But a nice thing about pandas as a library is it also accepts URLs. So I basically download this data from my GitHub. And this is now in a pandas data frame. You can view the first 5 rows using df.head. So for a regression task, I'll show you how to arrange your data. So I have a bunch of features like length, diameter, height, and these are all continuous values. And then from there, I'm just going to visualize how I want which columns are going to be in the features matrix. I just chose 6 or 7 random features, and these features will later be used to understand the relationship between our features and our target, which is ranks. So from here, it's advisable to convert your pandas data frame into a NumPy array. And the way you do this is by using the values attribute. So before, this happened to be a pandas data frame. And now we have a NumPy array. It's just advisable. So the next part is to create a target vector, and this is what we want to predict. So I have a pandas series here, and I'm converting it into a target vector. From there, I just want to mention that you can also arrange your data into a format appropriate for classification. Really, all that changes is that your target vector happens to be something categorical in the case of Avalon. So in this data set, it happens to be male, female, and I believe infant. So a couple common questions that people usually get with this stage, and I'm going to also just look at the questions here in case anyone has anything that's not LinkedIn related, which is perfectly fine. Oh. Okay, so why do we need to convert data frame to array? So in my case, it's a preference, simply because when a lot of libraries are built on NumPy arrays. So pandas is built on NumPy. So I find it to be less error prone in the long run. We'll see an example where we can use a pandas data frame in this talk. It's just, there's a couple edge cases where sometimes, occasionally back in the old days, data frames used to have a little bit of error. But for most part, these days, you can use either or. One question I actually do get a lot, data frame arrays last step. So this is after, of course, cleaning your data. So one really important part is you can assume your data is in a great format. But before you convert something to a pandas data frame or NumPy array, you should not have missing values because some machine learning algorithms do not accept missing values. They do not like missing values. You get an error. There are exceptions, like you can make it so decision trees, for example, you can make them work with missing values, but it's really just not advisable, depending on the library and other stuff. Additionally, when you explore your data, oftentimes you can find outliers or data that is badly documented or data that's just a multiple of a different column. And exploring your data is a really, really important concept, as we'll get into throughout this talk. And oftentimes when you explore your data, you can see relationships in the data that you wouldn't be able to see, or a machine learning algorithm by itself won't be able to see. We'll see later on this talk, we have a data set on predicting home prices in Seattle area. And the machine learning model doesn't think that latitude and longitude are very important in predicting home price. And as we know from just life itself, when you have a home, you often care where it's located. So if I have a job in Redmond, for example, and I'm trying to predict, or try to give a model to find out, the home's value, it really matters where it's close to my work or not, or whether in Redmond, for example, whether it's close to Microsoft for a lot of Microsoft employees. Chances are, just the fact the distance from Microsoft determines a lot of the home values in the area I'm in. So one question I do get asked a lot is, why is X a capitalized variable when we're creating a features matrix? And that's a really, really, really important thing. It's drives some math, really. So when we have this as a capital X, you can make it a capital X or lowercase x or whatever you want, really, any variable name. It comes from mathematical convention. When something is two-dimensional, when you have a matrix, it's typically capitalized in math notation. And when it's not capitalized, it typically is more of a vector. There's a really great Stack Overflow thing on this, which I don't want to get bogged down in. So all the notebooks I have here, I have some common questions in case you have them later on yourself, or if you just want to dive deep. So the next thing I want to cover, according to the talk, is about linear regression. And the first question that most people have when I talk about why we do a linear regression is that it's a really good idea to talk about things you already know to learn the syntax of a library, or things you most likely already have known or seen, to kind of understand how the Scikit-Learn estimator API works. So this will not only make more complex models easier to understand, so you understand the syntax of the library, so that your errors later on could be more commonly associated with logic errors, so not understanding what a machine learning algorithm is doing versus not understanding the syntax of Scikit-Learn. So in this little notebook, we're also going to talk about handling missing values, as even for a simple linear regression, it's very easy to make it so the model's not going to perform properly if you have missing values or values that are not in the appropriate format. So the first thing we do is we're going to import the model that we want to use in this notebook. And in this case, it's linear regression. We're also going to import train test split, which we're not going to talk about in this notebook yet. And we're also going to use the abalone dataset as before, simply because it's something that we've already seen, so it should be relatively simple. So one important thing to do before you do machine learning is to look at how many missing values you have in your data set, because in the case here, I may have changed the abalone dataset to be a little bit more inconvenient for you in case you want to follow along, where I made the length for one of the rows, just a single row for a single column value is missing. So it's really important to look for how many missing values you have. And what this code here does is null finds out how many, if something's a missing value in your entire data frame. And if I just look at this visually, it looks like there's no missing values here. And what sum does is it manipulates a property of Booleans in Python. Booleans in Python are a subtype of integers. So a true is a 1 and a false is a 0. So if you sum down all the columns, it'll basically be adding up a bunch of zeros here. And in the case where length happens to be true, there'll be a bunch of zeros plus 1. And so that's how you can find out how many missing values you have in your data frame. There are better ways to do this. It's just I like looking at missing values this way. So from here, you have a couple options. So for a missing value, you can either remove it. So remove any row, in this case, that has a missing value. This will make it so you don't get an error later on. Or you can impute it. And you could also, to impute, you could use the fill NA method. You can fill in with a default value. You can use some sort of machine learning algorithm to impute your data. So you could have filled in the missing value with the mean of the data. You could have done some sort of regression to fill in for the length value. But it's really up to you. And a lot of this also depends on domain knowledge. If something's missing in a data set, some data sets may have documentation to say, if something's missing, this row is no good, or we didn't have an observation for this column, or something. Sometimes missing values can be actually pretty predictive of the target you want to predict. So don't just remove them by default every single time. It's good to understand your data. So from there, you can arrange your data into a features matrix and target vector. In this case, because I wanted to show a relationship between one feature and the target, I'm only using one column for my features matrix. And notice here my NumPy array is two-dimensional. If you did this and for some reason you're getting a number here and a comma and nothing here, Scikit-Learn is not going to like that. So just note, in case you ever look at the shape of your matrix and it's not two-dimensional, Scikit-Learn will complain to you. So here's my target array, which is rings. So how many rings are on the abalone? And for the target, you can't have something being one-dimensional. This is fine for Scikit-Learn. So the way linear regression works in Scikit-Learn, like almost every model in Scikit-Learn, is you import the model that you want to use. And in our case, we imported it in the first line of this notebook, so we don't have to do this again. From there, you can make an instance of your model. And this is a place where you can tune the hyperparameters of the model. So in the case of linear regression, there's other things you can tune, but for Scikit-Learn, it's essentially fitting intercept equal to true. So do you have an intercept or not? And this is a really, really important concept, as a lot of more complex models have a lot you can tune. Hyperparameter tuning is a really big part of machine learning. And for linear regression, it really is, fit intercept, true or false. It doesn't matter so much. But it's just, this image is just to show that sometimes a single parameter tuned can make a major difference. So the R squared for fit intercept equal to false, when you want the intercept to go through the origin, is 0.86 for the case of this data. And the case here, the R squared is 0.98. And this is just from a different data set that's not super relevant. But it's just really important to just mention that these things really can make a major difference. And from here, we're making an instance of the model. So Scikit-Learn has a template model, essentially. And when you make an instance, it's basically just making a nice little copy, as we'll see later on. So from there, I also advise you, if you don't know the parameters for a model, you can always use the inbuilt Scikit-Learn or the inbuilt Python help function, and you can see what it does. So in the case here, I did my fit intercept equal to true. You can normalize your data if you want, and so on. There's really not that much you can tune here. But I advise you always read the parameters and what's outputted from the model. From there, you can fit your model in your data. So it's the instance.fit, and the model's learning the relationship between my x and my y. And this happens in place. From there, you can make predictions. So I'm predicting for one observation. So for one piece of data, in this case, I had the length. So for length of 0.455, I guess this is in centimeters or millimeters, I'm predicting number of rings is 4.9. So you can also predict for multiple observations, so multiple different lengths, and so on. And then from there, you can check how good your algorithm is. So because I only inputted one feature into my model, it's not going to perform very well. Additionally, linear regression has some assumptions, and that is that there's a linear relationship between my features matrix and my target vector. And in this case, there's not a super major linear relationship between my one column of data and the thing I want to predict. And then so from there, once you fit a model in Scikit-Learn, you can look at your different parameter values. So I can look at the weight of my slope, for example, which is 14.9. I can also look at the intercept. This would not have worked before I fit the model in the data, because the model didn't learn anything yet if I did it up here, because I just create instance of the model. There were nothing was tuned yet. It wouldn't have worked properly, I should say. And then from there, you can also get the slope intercept form in case you're familiar with that. So if you're familiar with matplotlib, it's often a good idea to try to visualize the output of your model as best as possible. So that way you can understand if the model's working properly or not. So this model is not really working super well. There is some sort of linear relationship between length and number of rings or whatever, but it's not a major relationship. And so from there, you can also visualize a model with or without an intercept. As you can see, it doesn't seem to work out too well either way. So there are a couple different ways you can improve performance of a model. But I'll look at questions right now and before I just go to some common ones. That is a great question. Okay, so let me see question-wise. So Willie, you asked, is Jupyter something I use to solve problems at my workplace? So when I worked at Scripps Research every single day, every former employer I've used has used Jupyter in some way, shape, or form. The one thing with Jupyter is it's not great for productionizing models. So if you go on Netflix, for example, most likely using Jupyter as it is and putting that model in production, it's a lot more complicated than that. But Jupyter is really great for trial and error, understanding your data, and then experimenting, because a lot of data science itself is very iterative. So what's the difference between parameters and hyperparameters? I'm glad you actually asked that question, because that's one of them I have here, at least for the next notebook. So I will answer your question, Ali, probably in the next notebook. I should also mention, if we don't get to all the notebooks in the 3 hours today, or in the 2 hours, or the Q&A session, I'm very happy to chat about it later, or just to give you the rest of the resources. So one thing that people are often curious about is, I'm just gonna leave it here, is the difference between an instance of a model, like what it is. So when we do things in, oh, no, my question is reference missing values better way. So what are better ways for imputing missing values? So one thing that I really skip over in these sort of talks, and this is something that a lot of people skip over, is that you can linearly impute your data. So if you know there's a linear relationship in one column, you can impute your data. If people fill in the mean as a missing value for length, for example, it'll affect the variance and the standard deviation of that column. So it affects descriptive statistics. And one of the best things to do when you have missing values is to understand your data set better. So if you're in a workplace, talk to the domain experts, the people that deal with that sort of missing data, or dealt with creating the database that you're querying from. Because maybe they know something about the data. If data is missing, it could be for 3 different reasons, or the data missing can be related to a different column or something. So often one great thing is understanding your data and communicating with the domain experts, because it's not just about machine learning. Usually it's about a business case. So if you understand what the problem being solved is, and also who collected the data, in case you're not the one that collected it, you can often get a good idea of what the missing values are, how to impute them, or whether they're just things you need to get rid of entirely. So other questions? Oh, so if you have missing values that are categorical, Vinny, I'll cover that in the Q&A session. I know that's a little bit away, but I really want to get to the next part of the thing. So yeah, so Ollie, one way to do things is, yes, you can remove outliers, assuming that those outliers aren't predictive of the target, because occasionally they might be. So that's one way. And if there's only a couple of missing values, if you have a billion records or a couple million, and you have one missing value, oftentimes it's not worth the opportunity cost of asking someone about it, or just spending a lot of time talking about it if there's only a couple missing values. If you have 20% missing values, well, maybe it's a data collection error, or maybe it's really, really predictive of some sort of outcome. So it's really important just to explore your data. And that's where matpot.lib comes in handy, and pandas and SciPy. It's not just about the machine learning aspect, it's also about understanding your data. So, next thing I want to cover is train test split. And the reason why we cover this is for a couple reasons. So machine learning models are about predicting the future and not the past. It's really great to have a machine learning model that can help you. Oftentimes, machine learning models are about predicting the future or making sure your model is very predictive of some outcome. And one thing with a lot of machine learning models, not really linear regression, is that they tend to overfit on the data that's trained on. So a model might work really, really well on your local computer. It might work really well for a given company, but when a model is actually deployed in real life, it might not work as well. And scientists have a lot of different model validation procedures to see how well a model would do on new data. And there's a couple procedures for this. One of them is train test split. You may have heard of cross-validation, which is essentially just a more complicated train test split. And here's how the procedure works. You split your data into two pieces, a training set and a testing set. So typically, it's about 75% of data goes to the training set and 25% to the test set. This is just a heuristic. Depending on your use case or work or environment, oftentimes this can be varied a lot. If you have more data, oftentimes you train on a larger piece of your training set. It just depends on the work, use case, and scenario. And then from there, you train your model on the training set, and then you test your model on the testing set, and then evaluate performance. One really important thing to note for train test split is this works great for a lot of different models. For models that are very highly biased, let's say linear regression, these procedures are not really the most useful thing, but we'll talk about that. For models that are high variance, these sort of mechanisms can really, really help the performance of your model in the real world. So for this notebook, we're going to import train test split because that's what we use. Scikit-Learn also comes with a couple of data sets that don't require loading from any website or importing any sort of file. And that's the Boston data set. We're going to import linear regression and decision tree regressor. So from there, we're going to load our data into a pandas data frame. And in this case, we're predicting house price. And I believe this is in the thousands of dollars. And it's also really important just to note that you can remove or impute missing values. And one thing I actually didn't cover in linear regression that I just want to briefly chat about is if you have missing values, you're going to have an error. And let me just show you the error really quickly. So if I just comment out this code when I restarted my kernel and just gone along with my day, so you get an error because Scikit-Learn is not great at handling missing values because it's telling you that you should have done something about a missing value. If you didn't do this and you actually cleaned up your data, then you wouldn't have had this sort of error. Okay. Let me see if there was a question about that. Okay, good. So from here, with the Boston dataset, it's a dataset from Scikit-Learn, so it's relatively clean. Real datasets in most scenarios don't have missing values. They oftentimes you'll have really hilarious outliers in some datasets. So it's really important just to see what you have. So from there, I see that there's no missing values. From here, I'm putting my data into a features matrix. I'm calling it X and a target vector. In my case, I'm only looking at 3 columns. I would highly advise that you play with this notebook or you play with whatever notebooks you use or environments and see about the effect of putting in more features on your prediction. So what we have here is a visualization of what's going to happen for a train test split. So for the code here, I'm inputting my features matrix and my target vector. I'm setting the random state equal to a number, which we'll talk about later. And the colors in the image indicate which variable, xtrain, xtest, ytrain, ytest, the data from the data frame went to for a particular train test split. It's not necessarily the same exact split as in the code below. And for those of you that are a little confused by this notation, if you come from a different language, one thing I always recommend doing is that whenever you have some sort of code you know what it does, see what the output is, see what it gives you. And in the case here, I want to see, let's see, what's the type of this variable? What does it give me so I can understand what's happening here? So it gives me a list. And what I'm doing over here is I'm unpacking values into xtrain, xtest, ytrain, and ytest. So let's see what the shape of these matrices are. And what you can see here, assuming I can type, definitely assuming that I can type, is that I have 379 rows and 3 columns for my xtrain, and 127 rows and 3 columns for my xtest. This was a split of 75% of my data went to the train set and 25% went to the test set. This happens to be my xtest. So this is my features matrix that I'll test the performance of my model on. And this is how the data that I'll be training the model on, the features matrix wise. Additionally, it's also just nice to see the shape of my ytrain. So I'll be training the data on this and this. So from here, it's the same process as before in the previous notebook. The only real difference is that instead of fitting my data or fitting my model on my entire data set, I'm fitting it on a subset of my data set. And from there, you can do the same thing. So one thing to note is that for train test split, these sort of model validation procedures work a lot better on high variance models because no matter what, in this case, I'm getting a linear relationship because it's linear regression. So for the score on my test set, it's 0.72, and on my training set, it's going to be like 0.66. So you might be wondering, why is it performing better on the test set when I was trained on the training set? And this is really just because I have a linear model. It's just random chance, really. And if I happen to do a different train test split, then I would have got a different result. Slightly different, usually. So one thing to briefly look at is what would happen if you had a more high variance model like a decision tree, and how would it have been different. So in the case here, I'm doing the same procedure, but just looking at linear regression training score, test score, as well as a decision tree regressor, train, and test. So one thing to note here is that my high variance model decision trees, which we'll talk about in the next notebook, they have a training score of 1.0, and on the test set, it had 0.66. So my model was overfitting for the case of the decision tree on the training set, so it performed pretty badly on the testing set. So one thing to briefly talk about is random state. So it really just a pseudo random number generator that allows you to produce the same result every single time you run it. So for a talk like this, it's to ensure that you get pretty much the same score as me because you're training your model in the same exact subset of data. If I did a different random state, I would have gotten a different result. Okay. 0.72, 0.71, and so on. And this would have varied a little bit too. So a couple questions I usually get on this are, how do we make that image? Okay. So, okay. So in case you're curious, because I don't have time to go over regressor in this talk, and I'll also answer in the next notebook if you come back on, what was the question? Hyperparameters versus parameters. I'll show you a couple examples of that. But since we're limited on time right now, I'll just show you how the image was made, just to reinforce the knowledge of how the random state parameter affects things, and also how the train test split is, in a lot of ways, randomized each time. So this notebook, I'm just going to go through really quickly. It's the same data set. I just want to show a train test split visualization. So one really cool thing is that for different random states, or if you just don't have a random state at all, you'll get a different result for your visualization. So the visualization right now has this data going to the test set, this particular row going to the test set, as well as these target values. And this darker color here goes to the training set. If I did things a little differently, it'll change the image around. So in this case, I only have 2 rows in the first 10 that go to my train set, and so on. So this can change every single time you do a train test split, and lets you set your random state to something else, to something static. And that's it for this part of the talk. I will answer questions really, really briefly, but we have to do a couple other things. So as Diane said, the next block starts at 1 p.m. Pacific Standard Time. And I'm really happy to talk about many more things there. I have way more material than I can possibly cover today. So if for some reason no one has Q&A questions, we will just keep on going with lecture. You can ask me literally anything in the Q&A after the next 1 hour session, which I think is at 2:30. There's a session at 1 that is more just like this lecture stuff. And then at 2:30, just lots of Q&A. Okay. Thanks, everyone. Hope you come back. So Matthias, we talked about Scikit-Learn like syntax quite a bit in the first session. However, a lot we'll go over this session is very similar in a lot of ways. So don't worry if it seems like we're starting out from other stuff or from a little bit higher of a level. We'll get, it'll be very similar, but just more in depth in the first session. Oh yeah, Matthias, yeah, this is a continuation. So once I get the go ahead to start again, I'll start. But it's just more detail. I'm going to answer a couple questions people had from the first session as well. And then the remaining questions are going to be answered in the Q&A, which is at 2:30, I believe. I can check them. So as far as the first session, I'll cover what happened when I get the go ahead to start in more detail, but essentially went over why would you use Scikit-Learn for machine learning and some basic syntax of the library, as well as some like do's and don'ts. However, I think you'll still get a pretty big benefit if you attend this session, even though we're going into more detail, as we go over more fun models, so to speak. So instead of going over like linear regression, we'll talk about decision trees, bag trees, and random forests if we have time. And maybe I'll show a couple animations, which I like making, and some visualizations. Okay, so Diane said we can start. So welcome back to Introduction to Machine Learning with Scikit-Learn. So a little bit of bookkeeping. So if you weren't here the first session, or if you just need the link again, here's a link to the material for the session, as well as the previous one and the Q&A. So previously we talked about just why we use Scikit-Learn, why it's useful, why it's important, et cetera, et cetera, et cetera. We cloned this to the desktop, or we downloaded the zip file. and unzipped it, and then we went through some of the material. In the first session, we got through 1 through 5 here. In the second session, we'll probably get through quite a bit more, if not all of it. If we don't, then we don't. I can talk about some of it in the Q&A as well, in addition to whatever else you're curious about, whether it be Scikit-Learn or jobs or whatever, as much as I possibly could answer. And then we'll have a conclusion about, like, Scikit-Learn is fantastic, but no tool is perfect. And I always want to talk about the pros and cons of anything we use, because just talking about the benefits of something doesn't deal with the drawbacks. In addition, sometimes Scikit-Learn is not an appropriate tool, so we'll talk about that too. So, and then I post everything right here, so you should be able to access the material. So from here, I have the material on my desktop. And just for people that were in the first talk, some people had some questions, and so I'll go through questions as we go. So one of them was Ollie's question on what's the difference between parameters and hyperparameters. And luckily, the next notebook we cover just happens to go over that. Someone during one of the other sessions asked about the train test split notebook, so how to keep a model after you train it. We'll talk about that during the Q&A, so next session. And Vidhi asked about categorical values, and we'll talk about how to handle those in the Q&A, as well as a bunch of other things, and whatever we have time for, in addition to whatever else people ask during the session. So with that said, let me open up these notebooks. So what I'm doing now is I have my DSGO material on my desktop, and it's in this folder. So I'm cding to that desktop. And then from there, I'm going to the directory on my desktop, and you can see that I have the same contents. By the way, if you're on Windows and you don't have Unix tools installed or different commands like ls, you could have done the same thing by using the dir command, but that's not super pertinent. I'm going to open up a Jupyter Notebook. And as far as the order, we're going to go over decision trees for classification, regression, visualization, back trees, random forest, and probably logistic regression if we have time, because I have more material than what I have on the online. So I advise you follow along with me if you have things installed, or if you're using Google Colab, that's great. If not, there's still some benefit of just watching these presentations. So the goal of this notebook is to understand how to create a decision tree model using Scikit-Learn. Recall in the last part of the talk before the break, we went over train test split with linear regression, and as well as a decision tree regressor, so a decision tree used for regression. And then one thing that we saw when we went to the notebook is that decision trees did really well in the training set and did pretty badly on the test set, relatively speaking. So we'll go over, why this is the case, understand these decision tree models better, as well as how to tune them, as well as some differences between classification trees and regression trees. So in this notebook, we're going over decision trees for classification. So those are decision trees used to assign a categorical value, like an example here, different flower species. So a Setosa flower, a versicolor, or Virginica. And one thing to mention about decision trees in general is that they're a relatively interpretable algorithm, as they're essentially just a series of questions designed to assign a class in the case of classification trees, or predict a continuous value in the case of regression. So, and one thing to really mention about decision trees as an algorithm is they can be used for classification or regression, whereas linear regression, as you might know, can only be used for regression tasks. So the way they work is essentially you start at the top node and you ask a question, is the petal length less than or equal to 2.45 for a sample? This is after the tree's been trained, by the way. Since this question happens to be false because 4.5 is not less than or equal to 2.45, you ask another question until you land up in a green leaf node or terminal node. The way predictions work for classification is you predict majority class. So in this leaf node, there were 38 versicolor and 3 virginica. And the prediction is versicolor as it was majority class. If you're curious about how how the model learns these questions and how it chooses these split points, split point in this case is 4.95, and that's where the tree diverges. Let me know, we can talk about it in the Q&A. I'm always happy to chat about it. So from here, we're going to import the libraries that we want to use. I always recommend importing matplotlib, pandas, and numpy, as oftentimes you're not just doing machine learning, you are transforming your data into a format acceptable for machine learning, as well as visualizing your data set, making sure there's not a lot of weird missing values, exploring your data to see if a given model is actually appropriate for your data, and so on. We're going to import the iris dataset because it's one of the datasets contained from Scikit-Learn. We're going to import train test split because it's a good model validation procedure. We're going to import decision tree classifier, as well as something called export text and tree. The reason why we're importing these two is that we want to visualize or create a visualization based on our model, and it really helps to visualize these tree-like structures. So we're also going to import our data set because this is the iris data set. It's very important always to see if you have missing values that need to be imputed or removed. From here, we're going to arrange our data into a features matrix and target vector. Recall that from before, our features matrix and our target vector, in the case of supervised learning, we'll be fitting our data on this feature matrix and target vector. So our model is going to try to learn the relationship between our x and our y. From here, we're going to split our data into a training set and a testing set. Note from before in the first session, this is just a sample train test split. So we have this here, and it's a 4-element list. And what we're doing is we're essentially unpacking this list into 4 variables. In the case of train test split, for the default values here, it's going to put 75% of the data into the training set. So this is our training features matrix. And we have our target vector, our training target vector. And then we have our testing features matrix and our testing target vector. And notice that this is roughly 75% of the data, and this is 25%. You could have tuned this to be 80-20 or 90-10 ratio-wise if you want, or whatever you want. So from here, we're going to import the model that we want to use. Recall from before that Scikit-Learn has a 4-step modeling pattern where you import the model that you want to use. In this case, we're doing a decision tree for classification. So you have to import decision tree classifier. I'm commenting this out because I already imported this at the beginning of the notebook. From here, we can make an instance of our model. And this is a place where you can tune the hyperparameters of a model. And hyperparameters are things you set as values before you train your algorithm. So hyperparameters are things you do before training. And I'll go into more detail on this at the end of this notebook. In this case, we're going to tune something called max depth. And tree depth is a measure of how many splits a tree makes before coming to a prediction. So depth of 1, 2, and 3. So that's a depth of 3 for a tree. This is deep depth of 4, and this is also depth of 4. One thing to note is that max depth is a hyperparameter for decision trees, but note that max depth is basically just saying you can grow up to a certain amount, but not anymore. So if a tree finds that the optimum depth itself after, say a max depth of 5, for example, is actually 4 because there's no point in splitting the tree even more. It won't grow to a depth of 5. So it's just an important concept. And then after we train our model, we can see what the actual tree depth is by using the getDepth method. And that depth of the tree is actually a parameter and not a hyperparameter. We'll talk about that as we get going. So we're fitting our model, we're making an instance for a model, we're fitting our model on the training set. We can make predictions based on the training of a model. So it's making these predictions based on what it learned from the training. Note that when it predicts a 0 here, a 1 or a 2, each of these numbers corresponds with a different flower species in this case. So I believe a 0 in this data set is probably Setosa, 1 is versicolor, and a 3 is Virginica. Don't quote me on that, but you have to actually look at the documentation. And then from here, you can look at model performance. So the default metric it gives you for score for a classifier, especially a decision tree classifier in Scikit-Learn, is accuracy, which is the fraction of correct predictions over the total number of data points. So it's kind of like you would expect. So I'm going to check the questions for a second before I continue. Oh. If you have a rare feature that you're predicting, is there any way to account for this in train test split so as to make sure you get enough in the training set? So you can stratify your sample. So you can get a proportion in your training set. You can also do a lot of class imbalance techniques like SMOTE. Noah, as far as accuracy only working in classification, one thing about machine learning that you'll find, and I'm sure you probably already encountered this, is that whenever you have machine learning, it's such a hot field these days that everyone's doing something just a little bit different. So there's always exceptions to every rule. So it used to be when people are talking about like neural networks, for example, and they wanted to classify images. People would be like, oh, you can. The best way to do this is convolutional neural networks, which are just a type of neural networks, are typically used for image recognition. And now people are using them for other stuff too. So there's no hard and fast rule of anything. But accuracy typically is for classification problems. So Matthias, and I'll answer your question in the Q&A session a little bit, because I want to get a good data set to showcase your question. Okay. So from here, we can tune to find the optimal max depth. Note that on these sort of like toy data sets, Iris or Boston Housing, all of these data sets, they're relatively simple. So performance, it may take a little bit longer to do this sort of thing on bigger, realer data sets. So we're going to tune to find the optimal max depth. We're hyperparameter tuning. And the way this code works is we're looking at possible values of max depth between 1 and 5 here. I just recall just from basic Python stuff that this is actually going to create a list from 1 to 5. Range, the thing to the left of the comma is inclusive, and this is exclusive. So it'll create a list from 1 to 5, just in case anyone has questions. So one thing to notice here is that the optimal value for the hyperparameter max depth is actually 3 in this case. Notice that the accuracy on the test set here for 4 and 5 is the same. It's always really important to mention that max depth is not equal to depth. So if you really were determining between max depth of 4 and 5, and you thought either one is good and it's giving the same depth, always check to make sure max depth is actually equal to depth. And I'll talk about that down below in the question section. So one cool thing about decision trees, this also goes for different sort of models, is certain models can give you different feature importance metrics. And classification trees, they allow you to calculate feature importance, which is the total amount that Gini index or entropy decrease to splits over a given feature. If you don't know what Gini index and entropy are, Essentially, in order to find the optimal split point, people use different impurity metrics, and I can talk about those in the Q&A section if you like, about how they work. But Scikit-Learn gives you a number between 0 and 1 for each feature. I should note that for feature importance values, they are metrics, they're not perfect. If you really like to understand what's going on in the tree, or just any other sort of other algorithm, understand how these metrics work, because occasionally they can give you some really wacky results. And in the case of this tree here, for the last one trained for max depth of 5, it says the most important feature is petal width, followed by petal length and sepal width. And note that if a feature has a low importance value, it doesn't necessarily mean that the feature isn't important for prediction. In the case of decision trees, it just means that a feature wasn't chosen at a particularly early point in the tree. So it wasn't chosen typically up here, but more likely down here, if it was chosen at all. It could also mean that that feature that wasn't chosen is identical or highly correlated within the feature. So just be aware when you have a metric for like a presentation or talking to a boss or whatever, that it's just good to understand how the metrics work. So when something goes wacky, and it will eventually, you know what's going on as best as possible. So with Scikit-Learn, after you train a model, you can visualize the decision path, so the rules for the tree, basically. And this is just another way to visualize what we had up here. So one common question I get from students is, how do you create a visualization based on the decision tree? I have an entire notebook on this that I can go over, time permitting. You can do it either using matpot.lib, GraphViz, or an online converter. So the reason why I use matpot.lib, at least in this talk for the most part, is that it's easy to work. So if you were trying to run my notebook and I had something that exports something called a dot file that is then transformed into a PNG image, a lot of students in this class would have trouble installing GraphViz on their computer because it's an external dependency and it's just a lot of work. Anyway, so you can make a visualization using matpot.lib. And the way this works is you just have your trained instance of your model, and you just do tree.plotTree. So I can see my tree, as I suspected from my feature importance, that petal width is the most important feature because it's chosen at a relatively high point in the tree. Because it's chosen as the topmost split, as well as the second topmost split. And I think the fourth as well on both of them. Wow, okay. So, and we'll talk about how to visualize these trees in more detail in a bit. So if you're ever wondering how to find the depth of a tree, after we did our hyperparameter tuning from before, one thing you can do is you can get the depth after you train a model by using get_depth. And this can tell you the actual depth of a tree. So in the case of this code below, all it's saying is that once we get to a max depth parameter value of 5, or hyperparameter value, the tree is just not going to grow anymore because it just can't grow, or it's constrained to grow. So it'd essentially just be a depth of 4 after you reach a max depth of 4. So, and as you can see, if we just did the same thing from before, just try to grow the tree even deeper, nothing would happen. So one student from before had a question about hyperparameters versus parameters. So if my talk is not sufficient, or you just want more information, there's an excellent article on it here. But essentially, just to keep it short, before we fit the tree, we specified max depth when we created an instance of a model, as you can see here. So this was before we fit. Parameters are typically things you talk about that are learned from a model. So when we're talking about linear regression, we had our coefficients. So our m value, so in our y equals mx plus b, that m and that b value were things that we learned. And in the case of decision trees for classification, we got our depth. Our max depth was a hyperparameter, and our depth was actually our parameter, because that's what the model learned. Additionally, we could also have done different things for decision trees, we could have limited the number, we could have got the number of leaf nodes. So leaf nodes, as you recall, are these green things here, and that's where classes are assigned or continuous values are predicted in case of regression. But that's kind of beside the point of this talk. So I will check for questions before I continue. So is it possible to create virtual environments with Jupyter? Yes. So this is one I don't have time to answer in the virtual sessions, but let me just send you an article. I wrote this when I was a grad student, but it's fine. So it just talks about virtual environments and just how to create your environments, and also just in case you're running some really old version of Python and for one project, and how to change environments and such. So this is your answer, Willie. Yes, it is possible. It's quite a bit of work. And let's see, what else we have? Before my computer does not like me. Is there a relationship between number of features and max depth? I'm sure there is, but it depends on the problem being learned in most cases. So I'm sure there's some study about that in excruciating detail. But I would imagine that as you increase the number of features, actually, sorry, you're thinking about depth, number of features and depth of a tree. So max depth, you just constrain to how much you can grow. It's a hyperparameter. So something is set before fitting your model. As far as depth, though, that is something that the model learns on its own. So I'd say there is a relationship between number of features and depth, because a tree will keep on trying to split if there's anything to gain from it, information gain-wise, which we can talk about in the session. Okay, I know it's a lot to take in at once. So I saw a nice little comment here that really speaks to me about GraphViz being a pain. It is a complete pain. However, let's talk about it, because I'm sure it'll come up. And then I'll do this a little bit out of order. I originally planned to go to decision trees for regression, I think, first, but we'll talk about visualizing trees first, because it's fun. So in this notebook, we'll talk about how to visualize decision trees with Python. So we saw how to do it using matpot.lib. However, I think it's nice to talk about other methods in case you ever want to do it yourself. You try to Google it, and GraphViz methods come up, and it leaves you unhappy. So, and also just to talk about that, there's many ways to accomplish a goal. Things I teach you in this session, there's not just one way to do things in Scikit-Learn or Python. It's all about getting the task done and doing it to the best of your ability in a lot of cases. So just know that there's multiple different ways to do something, and that there's advantages and disadvantages of every approach. So in this notebook, we're going to load some libraries. We're going to import the tree thing here. That's how we visualized it, using matpot.lib, essentially. Scikit-Learn and a lot of libraries function as wrappers, or they include matpot.lib in their libraries for a lot of different reasons. We can talk about it. It's one of my favorite subjects. We're also going to import decision tree classifier, random forest classifier, and more. We're going to load the iris dataset because we're running low on time, and I want to cover as much as possible. So before we can visualize a tree, we have to make a fitted model, because there's no tree or image based on a model if there's no model itself. So I'll repeat that again. There's no way to make a visualization based on a model if you don't have a model. So that's why we fit it first. So from here, it's also important to mention that this way to visualize decision trees using matpot.lib, this came relatively recently, as of, I think, May 2019, roughly. And this is because that making a visualization based on GraphViz, which is what I did here, it's relatively hard to do. It requires knowledge of something called the dot language in some cases. It requires you to install Homebrew occasionally if you're on Mac, depending on how you install it. On Windows, you may have to install another library. You can download something directly. It's just a lot of work. So here's how to do it using matplotlib, as we saw before. One cool thing about Graphiz is because it's been around for ages, there's a lot of different ways to specialize your visualization. So like I changed the text color for my output from Graphiz. I included more true and false values here because I understand how Graphiz works. Matplotlib, making the visualization using matplotlib is newer, so it's not as well tested as using Graphiz. So one thing to mention here is that when you do tree dot export underscore Graphiz, it creates a dot file, and that's relatively easy to do. It just requires a second. And that's a Graphiz representation of a decision tree, that dot file, and converting it to an image file is painful in a lot of cases. It just takes time because there's installations and such. So what I'm doing now is I have my notebooks in this folder here, and I'm going to create a dot file, assuming I can find where it was in my code. And you'll see this appear here. And this is really just something for Graphiz to interpret and create later, just a file. There are a lot of online converters where you can convert this to a PNG so you don't have to install things, which I can bring up in a second. Oh. So there's online converters that you can use just to make things like nice and easy. But, and this is really if you have like an assignment you have to get in, typically for like college, or if you just need something to visualize and you just can't install things and your day's not going well, you can do it this way. But that's not what we're doing today. So you can install Graphiz, and I wrote a blog on how to do this in extreme detail in case you're curious. So what this code does, if you happen to install Graphiz on your computer, is what this exclamation mark does is it escapes to my terminal and essentially runs a command for me. In this case, it's converting this tree.dot to a PNG file. But again, I don't recommend this. If this is frustrating, please let me know. You don't have to do it. Just know you don't have to do it. One really cool thing about visualizing decision trees is that a lot of models are actually built on decision trees. So what we'll learn about later, if we have time, are something called bag trees or random forests, which are essentially a lot of decision trees coming together to make a prediction. And this image above could actually be something called a bag tree or random forest, depending on how these decision trees are trained. And the idea of these sort of like ensemble models is that decision trees are a high variance model, and a way to lower the variance is to create a lot of them, trained on different data, so that you can get a lot of great performance from multiple models working together to make a prediction. Anyway, in this case though, what I'm going to show you is that you can make visualizations based on individual decision trees that compose random forest or bag tree models. So in the tree I trained before, which we can talk about later, I have 100 decision trees coming together to make a prediction. But what you can do is you can visualize each individual decision tree that comes together to make a prediction. And let me show you how that works. So one thing to notice about bag trees and random forests is you typically grow your trees longer, and we can talk about that. So, and what the code below shows is just the first 5 decision trees that make up a random forest model that I trained. This can take some time as a lot of these trees are grown pretty deep. Additionally, the other thing we're doing here is it's very taxing on matplotlib to visualize multiple of these trees because it's just a big visualization, so it takes time. If you're curious about what all 100 of them look like, you can run this code here. And then if you're on Mac, try to install ffmpeg, or if you're in Windows, still try to install it. But essentially what the code would have created would have been something like this, where you have 100 different estimators, and it just creates something like this. And you can see which is the most important feature. So anyway. Okay, so let's talk about more fun stuff. Also, notice, just in case you're not familiar with Jupyter, I typically close my notebooks when I'm done using them, especially since I'm taking up a lot of effort from my computer by running this essentially Zoom meeting, or Hopin, or how you say it. Okay. So the next thing I want to just briefly talk about is the fact you can use decision trees for regression. And the way this works is very, very similar. So instead of predicting some class, you're predicting some continuous output. So in this case, we're predicting how much a home is worth based on features like square feet, number of bedrooms, bathrooms, et cetera, lots of boring stuff. So in this notebook, we're also just going to talk about that a lot of data science is also not just about modeling, but also looking at the data. And we'll go over how to tune the model a little bit, which is very similar to classification trees. So here's an image of a decision tree for regression. And this was made using matpot.lib in case you want to replicate it. And in this notebook, I'm going to use something called Folium for a couple of reasons. One of them is that I want to show you how this works, like how sometimes a model cannot pick up on things that you think it should pick up. So you'd have to install Folium. If you're curious about how to install things and how environment management works, we can find time potentially to talk about it during the Q&A if there's time. So I imported Folium here. You'd get an error if you haven't installed it. So if you get an error, just remove it. I'm going to use the house sale prices for King County, which includes Seattle. It's a very similar data set to Boston, but just more interesting. And then from there, I'm going to look to see if there's missing values, which there's not. And then I also want to do some exploratory data analysis. So look at histograms, box plots, and more. Oh no, thank you. My bad. Sure. So Noah's question was, and thank you for letting me know I wasn't sharing. So I'm glad I didn't get too far. So how often do we actually use decision trees and look at the visualizations? It's mostly just to understand what the model's looking for, or what the model was interested in. Because one important thing for decision makers, depending on the task, is you can't use a model in production or to explain to your boss. Oftentimes people don't want models if they can't understand how they work. Because for some industries, let's say finance, you're not giving someone credit, or approving a loan, and you have to explain why you're not doing so. Oftentimes, for healthcare, if I'm predicting you have cancer, it's good to understand how the model is making the prediction. Because if you can't explain why something's happening, you might run into some problems. For other fields, where people just want to get the best predictive thing possible, then it doesn't matter so much. And oftentimes for like tree visualizations, it's rare that I actually look at like every single tree from random forest. But oftentimes there's something really weird going on. You go through every debugging step possible. You see, is the data that you're inputting in different than what you expected? Are there some really weird, things going on in your model? It's just debugging mostly. So, okay. So now that I'm actually sharing my screen, let's talk about it. So inside this notebook, which we can now see in theory. Thank you for everyone for letting me know I'm not sharing my screen. So this notebook, this is just a decision tree for regression, and we're predicting home prices. I'm also going to import Folium in this notebook because I want to show you that sometimes a model just doesn't pick up on things that you think should be obvious, like where home is located, to help improve the model. So if you get an error here, it's because you haven't installed Folium, and we can talk about how to do that later if you want. So if you get an error, just comment this out, or don't have it there. So we're using the King County home prices data set, and then we're seeing if there's missing values. And then from here, we're making some exploratory data analysis checks. So we're seeing if there's anything weird in some of our data. Oftentimes, if you have like really hilarious outliers or really concerning outliers, like if you had a home that was worth 1.4 billion, then chances are there was some sort of data issue, and you need to correct it because the model might not do well with major outliers. Sometimes people just remove outliers. They can talk about them, look at them. It's just nice to see. And I'm just doing histograms from pandas. And then from here, you can do something called a box plot. And I really like box plots because they can tell you basically just stuff of central tendency. They can tell you your 25th percentile, 50th, 75th. You can also do confidence intervals based on your box plot. So there's a lot of really cool things you can do. Okay. Yeah. So are there alternatives available? Or are there other ways to customize the graph to make it more intuitive for those audiences? Sure, there's always alternatives. And let me just show you one. So I should be better about blogging regularly. Oh, sorry. So there's something called dtree-viz, and this is just another alternative, but you kind of need to install GraphViz to do it as well. So essentially, it's just showing you distributions, like how the model is splitting. So that's one alternative. And the way you can kind of explain sometimes is by talking about feature importances and those sort of things. But it's all about knowing your audience. Is your audience technical or is it not? Or just kind of work from there. And this is just a library that was written by a couple very famous people. So 23 people, okay, good. So I have my box plots here. Essentially what they're showing me is that there's a pretty linear relationship between bedrooms and price, relatively speaking. And then things get a bit wonky when you start having 6 bedrooms, 7, those sort of things. Partially because I don't think there's a lot of homes in that price range necessarily, because they're more expensive, or that many bathrooms, so to speak. You also have 33 bedrooms here, so it seems a bit interesting. But just sometimes looking at the data can give you some sort of insight. One thing I'll briefly want to mention is that there's quite a big difference between the smallest home, cost-wise, and the home that's the most expensive. So from 75,000 to, wow, almost 8 million. That's a pretty big difference. So I always recommend just looking at these sort of things, seeing if that's an outlier, et cetera. And then what I want to do now is just show that sometimes there are kind of interesting relationships if you look at geographic data. But oftentimes models really can't capture it because you don't have data that a model can understand in an intuitive format. So oftentimes home prices, like I talked about in the first session, are about where they're located. And companies like Zillow and a lot of other companies also calculate things like distance to companies, distance to good schools, school ratings. They have distance to water. They have all sorts of great data. And if our model doesn't incorporate that, then the model can't learn it, at least directly. So I did not import Folium. That's why it's saying full name is not defined. So what this is doing is I'm just trying to briefly show, not making a good visualization necessarily, that there is some sort of relationship between like where home is located and the price. And I'm doing this, I scaled the data a little bit so that you can kind of see the price based on quantiles. So from the 1% to the 99% and so on. And give it a second because I'm creating something in HTML. While this is running, I'm going to look at questions. There are none. Wonderful. Okay. So while this is destroying my computer, let's go into the next part. So from here, we can arrange our data into a features matrix and target vector, as usual. And as you'll see in this talk, a lot of this stuff is very formulaic in a lot of ways. So you can then do a train test split and then fit a model. Notice that the depth of this model without training is 39. And this may not seem like it's working very well, but if you don't give the model the best possible chance to succeed in life, it's probably not going to do so if it's a high variance model. So we can do the same sort of thing we did before with classification trees. And then one thing you'll notice is that on the test R squared, after a certain max depth, the model just, falls off a cliff in terms of performance. So it's really important to just try training a model and see what you get from there. Also important to note is that we didn't really try super hard here. We have a lot of features that we looked at, but in the features matrix, we really didn't include actually that many features. So if you're playing with this yourself, I encourage you to try adding and subtracting features and see if you can improve the performance of the model, because I can almost guarantee you can. So a couple common questions for this are, how do you create a visualization based on a decision tree, which we went over just previously? How can you create a better model? And a lot of this is just about data. So really nice to add better features. It's really important. So a lot of data, like science for machine learning, is just about creating better features and getting better data, and also trying multiple different models, which I don't think I have time to cover today. So another thing to talk about is which max depth was best, and why was the test R squared so low? And that was really just because we overfit on the training set. Take a second. So the best model in our case was for a depth of 6. Okay, let me just show you. So the best model is maxed up to 6. The actual depth was 6. And the train score was 0.61, and the test score was 0.51. Yeah. I'll answer your question, Noah, in a little bit. So we can also visualize this. One thing to note is that in real life, the trees get rather large. So oftentimes that's why people look at feature importance metrics, because sometimes the trees just get so unwieldy. But occasionally, as things get really weird, you have to look into the trees themselves. But it's kind of rare. So one thing to note from this graph is all I'm showing is that as I was tuning max depth, the test score went up for a little bit and then fell off a cliff. But the train score was just getting better and better. So there's always, when you're tuning a model, you want to make the model predict the future and not so much the present, and predict well on out-of-sample data, i.e. data that's not trained on. So if you just let the model grow as much as possible, it's going to do fantastic on the training set. In a lot of cases, it'll memorize the training set, which is not what you want. So the best models around here. And this is just a dual axis graph in case you're curious how to do one. Just to show you the difference between the relationship of when the test R squared is going up versus when the train R squared is going up. Oh. So Noah, your question about grid search, and for those that don't know, grid search is essentially trying every different hyperparameter value for the parameters that you're interested in tuning. So in 8 minutes, we'll come back. Or in 8 minutes, we'll do a 30-minute networking session, and then we'll come back here for Q&A. Grid search tests every single thing, but it takes a lot of computational power because oftentimes with grid search CV, if you're doing like 10-fold cross-validation, essentially just 10 train test splits for each possible hyperparameter value, it means a lot of training. It means a lot of computational power. So it takes a lot on your computer. So it's a good approach. You can also read about something called random search if you like. I'm sure you probably know about it. And that's essentially a smarter way to not try every single hyperparameter value and just choose the ones that are more likely to succeed in getting a good model. It's not always going to be as performant as the exhaustive random search or exhaustive grid search approach. But if you have computational power, yeah, it's a good idea. But it's also just how much time do you have in some cases. So one thing we'll talk about if there's time in the Q&A is which model do you use? And a lot of that really is based on the task. So do you have computational power? Does it take more time to train? Not just computer time, but also developer time. So when you get into like neural networks, for example, they might work better, but they could be less interpretable. They could also be a lot more work for the developers to train and also the computer to train. So it's all just about your use case, as you mentioned. So we have a couple minutes left before we go on to other things and then come back in half an hour for like 2:30. So after this session, we'll talk about bag trees, random forests, and a conclusion, essentially. Actually, I'll give a conclusion now, and then we'll do more stuff if you want to talk about more in the Q&A. So I have 6 minutes to go. Let's make this quick. So as far as Scikit-Learn, and we'll talk about more in the Q&A if you want to about just Scikit-Learn, other models, etc. There are some disadvantages of Scikit-Learn. And one of them is that a lot of Scikit-Learn models don't parallelize as well as other languages, libraries, frameworks. Because if you're growing multiple different decision trees for an ensemble model like a random forest, for example, you can do a lot of that in parallel. You can bootstrap your data and then grow a tree. And Scikit-Learn is just not built for that as much. You can do a little bit of it by changing an nJobs parameter, but it's not really super pertinent, not really that fantastic. Scikit-Learn is also not widely used for deep learning. There are a couple of feed-forward neural networks in Scikit-Learn, but for the most part, you're better off using other tools and frameworks. So as far as where to learn machine learning, because 2 hours of this is not enough time to learn machine learning, I have a lot of recommendations, so please let me know. But I like the Introduction to Machine Learning with Python. I find the book's a little dated now in terms of just some of the code, but the visualizations are great, and I really like visualizations, if you can tell. I like this book a lot, Hands-On Machine Learning with Scikit-Learn, Keras, and TensorFlow, because I just find it goes well together, as well as the Python machine learning book. I have this book right next to me at all times because I teach a lot. And there's other books in case you want all the theory like pattern recognition and machine learning, as well as elements of statistical learning. This is more mathy. This is in R, from what I remember at least. It's been a while. And then the Python Data Science Handbook is something you can find online from Jake von der Plas. And it's pretty simple. There's other courses. So is Coursera, machine learning. I don't recommend the MATLAB part of it. You want the theory. Machine learning A to Z is pretty good, as well as the Coursera deep learning specialization. If you like PyTorch or FastAI, there's a FastAI course. I also have a LinkedIn Learning class in case you want to do that, in case you get it from your work. Please let me know. I can send it over. And that's it. I hope you've enjoyed this talk. I will do more during the Q&A if you want me to. And I hope this talk is posted on YouTube eventually, but that's up to the organizers. But it'll be posted somewhere if you were able to see this session. So stay in touch. Feel free to connect with me on LinkedIn or Twitter at Learn with Michael. And in the Q&A, we can talk about logistic regression if you want. So really quick, we answered this question. So Stan Green asked, this was a while back, in the train test split notebook, I see how the training takes place, but I don't see where the training is saved. So once you make an instance of the model and fit it, the training is saved inside the instance. So how do you use it if you restart your notebook and you just want to save your training so you don't have to do it every single time you open your notebook? So there's a couple of features I'd encourage you just to look at. This is pickling a model. And essentially, after you fit a model, you can import pickle or before and basically save that object so you can then load it again and then use your model. So you don't have to redo it. So just, I know this is a question from like way back in the day, probably like an hour or two ago. And the other question from Vidi is about if we have missing values that are categorical, how do we handle that? And this is the second to last question that people asked. So a couple things. Missing values, I talked about before, you can remove them, you can do whatever you want. Things like gender or sex, however you want to describe in your data set, however people describe it. It really depends on domain knowledge about how you want to handle that and the use case. So I would be asking HR about that in some cases because it depends on what's going in your data set. And Matthias asked you about rare feature that you're predicting. Is there any way to account for train test splits so to make sure you get enough in the train set? Yes, you can do things like SMOTE, which are essentially just upsampling the smaller class and downsampling the more common one. You can do something like this, but it's not the, you know, a perfect solution. Nothing is ever going to be perfect. So I'd encourage you to read about it. Additionally, even though we're not going to go over it necessarily right now, based on if people have questions, one thing that I provide here as a resource that's based on an article from Machine Learning Mastery and something else I wrote is there's a notebook on logistic one versus all, which I'll post after this talk is over, which I just used from something else I've done. And essentially what you can do for train test split is you can stratify your sample in case you have imbalanced classes where one is a lot more common than the other, or a lot more common. Like spam is typically, if you have like fraud or non-fraud, typically fraud is a lot less common than non-fraud in a data set. So you can stratify samples, you can do a lot of different things. Okay, sorry. Now back to the actual session of questions. Sorry for hijacking that there.
Hey, Michael.
Hey.
So I'm not sure you understood the question.
Sorry.
So we do a lot. I hear about all this model training and stuff. We do, 10 million images, and then we want to take it and put it into production and send an image to it and go from there. But so how does that model get into production, I guess, is the real question.
So at the same time this talk was going on, Luca gave a talk for the past 3 hours. So I'd recommend you look at that because he goes into excruciating detail. So there's a couple ways to approach this just to really give a high-level overview. So you can save your model. You can save the object that you trained. Pickle, that's one option. For a lot of people that have models, oftentimes people Dockerize their model. They use Docker containers and deploy it that way. Okay. There's a lot of different ways, and really, I think you should just go see Luca's thing, or I can send you other resources.
So you put the object, you save the object in a Docker container and go from that.
Yeah, that's one way. There's so many different ways. It's not particularly my field.
I thought, wasn't Lucas an Oracle solution though?
I have to check exactly, but I know his went on for a while. I saw part of it when I was in between
Okay.
my sessions. So.
All right, thanks.
Yeah, I also like your background.
Thanks.
Hey, Michael.
Hey.
I may have missed this in one of the previous sessions, but I was wondering if you could possibly explain a little more the difference between a parameter and a hyperparameter in a model.
Sure. So inside this notebook, we talked about like parameters versus hyperparameters a little bit. And one of them for classification trees and also regression trees is tuning max depth. And this is something you do before you fit your model, is set values for hyperparameters. So for a decision tree, it can be max depth. For something like a random forest or a bag tree, you can set number of estimators, which is how many decision trees you want for a prediction. You can tune that. And that's something you set before you train your model. And what you get in the end is you can get other things like, actually train here? Oh, I have to actually show the output. It's not important. But there's also other models like logistic regression, and there's hyperparameters in that. And one of them is you can tune what's called a C-value. And let me actually just go through and show you. I know it's a lot for one question. And by the way, this notebook will be available for you later on. Okay, I know it's long. Okay. So with logistic regression, you can use something called C, and this is a regularization parameter. So smaller values are stronger regularization. And without strictly speaking running this code, you can get that. But logistic regression also gives out coefficients and essentially an intercept for the model after you train it. And those things that you get after you train the model are parameters of the model, because that's what it learned after fitting the model. So oftentimes you want to tune these sort of things for a lot of different reasons. And just for reference for the logistic regression one, let me see if I even have this. Okay. These things that you tune before the model can have a dramatic impact on your performance. So a stronger value of regularization, i.e. smaller C-value, means that you have the model is learning less the relationship between the features and the target, but trying to generalize well. And in this case, there's no regularization when it's really high. And then what you get out of this model after you get a C-value, after you know the C-value, you fit the model, then you can get the coefficients and the intercepts, and those are your parameters. Oh, did I quit sharing? Sorry. Sorry, could we get back to Matthias? No, internet. Yeah. Sorry about that.
I hopped off.
Okay, sorry.
That's helpful.
Yeah.
So the parameters you do before you like train your model and run it.
Mm-hmm.
Parameters are like the specific like slopes and intercepts and stuff that the model gives you after you've trained it and ran it.
Mm-hmm.
Cool.
Yeah. There's also an article that Sebastian Raschka wrote. I actually have his book with me like almost all times. It's one of my favorite books. Fantastic.
Okay.
So
cool. Mm-hmm. Thanks, Michael.
You're welcome. So if for some reason we don't have questions, you can ask me almost literally anything. It can be about this talk, it can be about careers, it can be whatever. I'm happy to answer whatever you want.
Hey, Michael, how's it going?
Good.
I have a couple questions. Hopefully we can get through them pretty quickly. First, do you have a good resource for kind of doing a deep dive into hyperparameters for models that you're not super familiar with? Rather than just like randomly guessing what they should be?
So it's about, for me, it's about understanding the model rather than, and then going from there. So I do like this book here. I just brought it up, but I really do like it.
Okay.
It's a fantastic book because I understand what's going on with the algorithms a lot better after I read it. It's also, I use it for I like the code examples. So I find it very nice for my understanding, also for teaching, which is not always pertinent. So there's that. I think also the machine learning A to Z classes is pretty okay with like an intuition for model. So you understand what parameters are more important. So okay. I like that. That's one is on Udemy. I don't know how much it is though. You can probably get a discount code or whatever.
Okay. And then you also talked about some weaknesses of Scikit-Learn.
Yeah.
And I was wondering if you had to recommend another package to kind of complement Scikit-Learn that would be good to pick up, you know, within your first couple of years as a data science professional, what would you say?
So these days, the skill sets are always changing. So, you know, don't quote me on this 3 years from now. But
yeah, of course.
I'd recommend learning Keras or PyTorch, because when you learn Keras, you know, essentially learn TensorFlow these days.
Yeah.
Simply because people care about deep learning so much. Even if your job doesn't do it, oftentimes people ask about it during interviews. Okay. So in case you want to change jobs or like whatever, yeah. I think it's very, very useful to know. I prefer Keras just because it's easy. And additionally, it's more efficient. So you can do like normal machine models or normal machine learning models using Keras and TensorFlow, for example. And they're very efficient. It's just harder to program.
Okay.
Yeah.
Okay. Okay. And then kind of in relation to that question, one of the packages that I've experimented around with a little bit is like stats models. And one thing I like about that is it does a really good job of giving like summary stats. I come from a research and R background, and I've always felt like, yeah, I've always, or I liked how it gives you lots of summary stats and they're easy to access, and you can kind of get an understanding of how your model performed in different, you know, ways. And I know that with Scikit-Learn, I feel like I have trouble accessing that information.
Yeah. So like p-values, for example, for like logistic regression, you have to do that yourself, but luckily, like you can always Google it and go from there. It also helps you understand p-values more. But yeah, I know it's annoying. So that's one weakness of Scikit-Learn as well. It's a lot of the default parameters are good, but some of the output is not always from like a super stats background. And if you want to know like which feature is most important for prediction, then in like a simple logistic regression model, then you have to do other things like. For example, for an L1, like logistic regression with an L1 penalty, like, let me just show you an image. You don't have to leave the slide or anything. But like for like stats models, it's really easy to get like which features are really important for prediction just by, you know, seeing that which feature is most important. But for Scikit-Learn, for example, you have to see which feature goes to 0 when you do like essentially an L1 penalty for logistic regression. Yeah. The fastest, and it's kind of just annoying. Yeah. So I probably have another notebook open that shows this as well. But anyway. Okay. But I can bring it up later somewhere. Okay. I'm just, you know, I'm glad to know I wasn't like missing some feature. No, I mean everything has strengths and weaknesses. So that's one thing I just didn't include because, you know, yeah. Okay. I don't want to take up all the question and answer time. I might send you some other questions later, but that's all I have for now. Sure. Thanks. Thanks.
Hi, Michael.
Hey, Matt.
I have a couple quick questions, so I don't want to take up too much of the time. One, could you explain pickling in more detail? And if you want to bone up on like basic programming, like in Python, like what would you recommend, like for good resources?
So
I'm coming into data. I've been doing data science, but I'm a recent Python convert. I'm not a programmer.
pickling is just saving the object. That's all it really is. There's more detail than that, but I honestly don't want to go into more detail because I'm not like pickling objects every day of the week.
Okay.
So it's just really, it's serializing a variable. It's keeping it so you can use
Okay.
it later. And that's kind of like when people come from like MATLAB, for example, they're used to saving their, you know, the variables between sessions.
Yeah.
Yeah.
Okay.
Think of it
That's
like
all
that.
it is. Okay.
Yeah. But people do this as they train a model. They put it on some, you know, API or they do Flask or whatever. So it's that. And then what's the other question?
Just to bone up on basic Python programming, like what would be a good resource you'd recommend and to get better?
So the person I like the most is Corey Schaefer. He's a YouTuber. You just open it up without sharing my screen. So I like him a lot because he's very good. He understands what he's doing. He's very, very competent. Great for Python. One sec. Let me just put it in the chat so that other people can see it too. I like his like object-oriented Python, for example, because oftentimes when I'm teaching classes, I don't have time to teach about like, you know, basic object-oriented stuff and decorators and all that stuff. So I like him a lot.
Okay.
Yeah.
Well, thanks a lot. I appreciate it.
Mhm.
And these sessions were great.
Thanks.
Thanks.
Okay. Hey. One second, I can't hear you yet. Not yet. Can't hear you yet. Is there any way to fix it? Maybe ask in the chat window. I know it's not as personal. And I'll answer your question about next steps whenever the videos are good.
Hey, Michael.
Hey.
Can you hear me?
Yep.
Okay, so I think I can ask while Graham is writing his questions. So I actually have two questions. One is that when you're starting with machine learning, Scikit is always obviously a really good tool to get you started and everything. What are the other tools or kind of that are commonly used or something that are more upcoming that we need to keep our eye on, or you find them very useful?
So if you're coming from an academic background, as mentioned earlier, stats models is good. I do think just learning some deep learning framework is useful, even if you have no plan to do deep learning for work, because that's what people care about these days, even if it's not relevant. So even if like your boss is like, oh, we should try deep learning for something, you know, even saying, you know, oh, this is not appropriate for a problem because of X, Y, Z, or, you know, understand different frameworks is good to know. So at least know the difference between, you know, PyTorch and Keras and TensorFlow, and that's really useful. So.
Okay. Okay, that makes sense. Second question is basically, what's your daily job at Coding Dojo like? So as a data scientist there.
Oh man, so these days I'm doing more teaching. So it's not really a typical sort of job anymore. So why I went to teaching is a completely different question, but a lot of my day-to-day job is now building curriculum, like fixing boot camps. I'm speaking for Microsoft Reactor like 9 times in the next like month or so. it'd be exhausting, or how much they want me to. So that's part of my job, and mentoring other instructors, and dealing with issues like chats not working and that. But before my day-to-day job, when I was working at Scripps Research, a lot of that was really just data quality, as everyone says their data is fantastic, but you try to put it into any sort of model, and you're just like, oh no, that's wrong, or this data is not as like real as people say it is, or the default values, the data in like a database are like impossible. So it'd be like anything as simple as someone, God, what's a good example that's not going to tell too much about my job? So someone puts a default value for sex, for example, in a database, and you get the data and it's like, oh, this is not possible. Or default values for heart rate or sleep or whatever, just terrible. So, and then modeling off that. Yeah.
Okay. Thank you so much.
Yeah. Okay, so Graham had a question about next steps. So you just completed a Udemy Data Science Bootcamp, and you are an Oracle database designer. So Alvinish asked a similar question about what is the next steps for someone transitioning over data science. So one of the biggest things about transitioning over data science is know what you want to do. So every job is different. So like it could be as simple as going on Indeed, seeing what jobs are out there to know what you need to know. So it's really as simple as, let me see if I have a browser. Like looking at jobs and then working backwards. So now, so find out what job you want in the area, learn the skills or make sure you have the skills. And then also going on Glassdoor and seeing like, what do they ask for interviews? Because oftentimes with, data science jobs, you have to, see what's out there, see what you need to know. So if I was interested in working at Pinterest, for example, I need to know, oh, they really want people to know SQL and Hive as well as, Python and R or whatever. So if I need to know, go from there, and also look in Glassdoor because you got to pass the interviews. The other thing I would encourage is, do you have a portfolio of what you can do? So do you have proof that you can do more than you just say you can do? And that's a really hard sort of thing because even if you have a referral for a job, you still have to pass the interview. You still have to be able to show people you can do the job and that sort of thing. So if you did data science bootcamp, you can also do more classes. So based on what you don't know, based on the Glassdoor interview questions or whatever, learn it or try to learn it. Mm-hmm. Mm-hmm. And more questions? Oh, let me stop sharing my screen. We can ask about just individual questions or models or whatever. I can also just talk more about, different anything if there's no more questions. Oh, cool. Another question.
Hi, first of all, thank you so much. It was very engaging to follow your notebooks and lots of information, and for a future, even may not necessarily everything absorbed, but going through again, it will be great to keep those notebooks. Something that I have seen that people are being asked at the interview, so it will help others as well. That I hear that interviewers asking, "What is your favorite model?" And I know my answer exactly. And that you don't want to necessarily start laughing in the face because it really depends, right? But what do you recommend? What would your answer would be? And it will help to our data science community, I'm sure.
So don't quote me on this one because interview questions, I would always recommend, studying like crazy, but it really depends on the context, as you know. So let me just share my screen again. And I didn't get to cover everything I wanted to cover in this talk because it's impossible. And I'm always disappointed in how little I cover. So under the random forest notebook, I have a lot of common questions. So what are random forests, blah, blah, and all that sort of fun stuff. Difference between bag trees, random forests, and all that stuff. So I have a little text I wrote about this. This was originally from a course I taught. So it depends on what you're trying to solve. So my recommendation is figure out the problem you're trying to solve. Do you need something more interpretable? Do you need a model that's gives a predictive probability? Do you need something that is computationally faster or easier to put in production? So that's also the thing, right? More complex models are more difficult to maintain. So I'd ask, like, what's the problem? And then I'll go from there. I'm very much a problem solver kind of person. But,
right, and it's probably also heavily dependent on data set that you have as well, because not every model applies to every data set.
Yeah, and as you're right, so there's no modeling without data. So, and really, it's also urgency. So it's not just what's more difficult to maintain, but like it's really easy to fit like a linear regression to if you have a linear data set. But neural network or a more complex ensemble model where you have an SVM here, support vector machine, that's also coming together with a neural network here and something else like a Kaggle style kind of model. That's a lot of work for developers to create. So yeah, that's kind of my answer.
Thank you. Thank you.
So Avinash asked, unless the moderator wants something else to happen. Avinash asked, do you have any preferred or favorite Python library? Not really. This is what gets the job done. I use matpot.lib a lot because I'm an instructor these days. And also when I was doing a lot of research work, a lot of my job was communicating results to people, and no one would ever use a model unless they understood what it did, or had a pretty graph in some cases for the really higher ups. So a lot of visualization was really important to my career and life. And also I blog on the side, so I love matpot.lib, despite how difficult it can be at times. More questions? Any more questions, Diane? Okay. Cool. So you can ask me any question about careers, life, jobs, applying to jobs, referrals, data science as best I can. Ask me anything really, and I'll see if I can answer it. If not, I'm happy to talk about something else, like data science related. Sure. So one big thing about, okay, I'll answer referral one and then why did I move to teaching? So as far as referrals, I get this question a lot, and so that's why, also because I just released a video on YouTube about it. But one thing about referrals that people always say is oh, to get a job, you have to have a referral to get a job. And there's some truth about, referrals do help, because there's always someone that gets a job that, it's through a referral friend or whatever. But one thing when you message random people asking for a referral, oh yeah, I'm looking for a job, do you have any positions that, fit my skill set? One thing people do is they say that kind of message as opposed to hey, I looked on the website, I'm interested in this, applied scientist role or, data analytics specialist role or whatever. And then here's why I'm, good for the role. That's a lot more effective than just being hey, I was wondering if you could look through your, on your own website and see if there's any jobs because I'm, too lazy to look, There are jobs that are hidden from view sometimes, but it's for bigger companies, oftentimes what you see online is what you see online. There's very similar roles at the company, like that are internal as well. So it's really good to just actually do your research yourself as well, and don't just ask the person that you want the job from to do it, because the request will take in better because it's less work for the person for the referral. So Ollie asked, why did I move to teaching? So my undergrad was very unpractical. Like, we're talking, you know, not useful for data science at all. So a lot of my undergrad was in nanoengineering, which essentially is just like really, really small things. And a lot of it was like, you know, steering red blood cells with ultrasound and like, let's see, like destroying nerve agents with like just crazy things with nerve agents with micromotors. So there's a lot of like random things I did in undergrad. And I got into data science. I want to get into data science because a lot of what I did happened to deal with data quality issues and like manipulating data, getting data in an organized format. And I realized I didn't have, you know, the skills required for data science jobs. Also, I didn't have anything to show employers. So a big part of life is having a portfolio to say like, oh yeah, like besides me telling you I can do something, here's like all this proof everywhere. So I got into teaching a little bit because it was experience, like data science experience, and helped me with interviews. Because, you know, like Graham asked about like, oh, is there standard set of data science interview questions? So when I did teaching and like enterprise teaching, it was a good way to pay for grad school too, because enterprise teaching means that like you make quite a bit of money, you know, teaching for 8 hours a day or whatever while I was in grad school, which is very nice. And then people started asking me like, hey, can you do, you know, teach at, you know, this university or do this LinkedIn Learning class or whatever. So I kind of just got, you know, into it. Teaching itself, I wouldn't always recommend it because it's longer hours than you would expect, because oftentimes you have a client in the middle of like across the world and they want you to teach. Then you might have, you know, some weird early mornings, late nights. Pay is also typically is quite a bit worse than just a normal like tech job. So, but as far as like, I'm going to butcher this name, so I'm very sorry. So I'm just going to do Marielle de la Cruz. The most rewarding part about teaching is, you know, this. I get to have people's attention for a couple hours on a Sunday. This would never happen in tech, or at least unless something is really wrong or, you know, you're hacked or whatever. So I might eventually go back to like, tech work eventually if, you know, no one wants me to teach anymore, but it's nice. It's definitely nice having people's attention, time, and also having things that people can find me from. Like if you Google my name, it's nice when people like read my blog and, you know, it gets attention or whatever. It's just a nice way to wake up. And as far as newcomers, for Sasha's question, how effective is cold applying? I think the problem people have is they think the only way to apply is to have a referral, like, which I think is nonsense, because you don't hit the shots you don't, you know, shoot. Additionally, for a lot of places, you know, you apply and then, you know, someone can refer you for the job, you know, after. So yeah, and Stan, it's great, you know, changing someone's life. It's great too. That's a lot of satisfaction after this too. But yeah, you have to apply online too. Don't always just worry about just having a referral. There's talks about like Kaggle Data Science Con, and I'm actually looking forward to something to send you. And I really do recommend, you know, making a portfolio, going through the resume section of this, just to see like, you know, what people expect. Because actually like in that one section down below, there's like a section on like, oh, here's how you do a resume, and someone critiques data science resumes. So I would recommend it. It also depends on your background. So if you were, you know, in school, for example, I think someone in this talk was already in school. So it helps, you know, to have interned, you know, in the past. So if someone's already in school, intern before you just apply for a full-time job. because a lot of places take recent graduates as interns and stuff like that, versus the bar to entry for like a full-time role is a lot harder. So yeah, but a mixture of applying like cold applications, referrals. Also, if your resume isn't getting attention, then look at the article I sent you about like the resume format and portfolio building and that sort of thing. Because it used to be that you just graduate from college and have a bachelor's degree, then you apply for a couple of jobs, and you're like, oh, we really want you. Now it's a bit harder, which is very sad in a lot of ways. So I think did I answer the question, kind of? Okay, and good job, Stan, about pickling a file. Avinash's question about Kaggle competitions. So some jobs, they like to see that you've done a lot of model building because it's good to see. But it's also good to understand, how Kaggle is different than real life. Oh yeah, working with recruiters definitely helps as well. Especially if you're doing like contract roles, it's a good way to get experience so that like if you're just applying the top jobs at Google and whatever, and you want to start at a very high job, whereas if you just take like a contract role from a recruiter or whatever, it's some experience so that when you apply for a job, your resume is more bulked up. Whether if you stay unemployed for years, it gets harder and harder to get the top job. So I think the biggest thing when I tell a lot of students is like, when you take a job, it's not forever. A job these days is not for 30 years anymore. So oftentimes people take a job for a year, 2 years, because that's the job that'll have them, and that's the job that's right for the time being. And Avish's question about like Kaggle competitions, it's good for understanding machine learning, but know that it's not always like real life where your data, they give you the data in a relatively okay format. You do a bunch of machine learning models. You spend a ton of time trying to optimize your performance. And in real life, oftentimes you have a model that's good enough, and you don't have to go for the extra improvement in your score or accuracy or R-squared or whatever metric you're trying to optimize. So it's important to learn modeling because in real life, most of your job is working with data, like cleaning data, that sort of thing, typically, unless you have a pure machine learning research role. So it's the chance you have to practice your machine learning skills typically and go into different data sets. Additionally, it looks good on a resume if you place highly in competitions. And the article I posted, someone talked about like, how you advertise your Kaggle like profile and that sort of thing. So yeah, so networking is also important. It's also one thing she mentioned is if you start networking when you're looking for a job, it's kind of too late. One thing I just want to mention during a pandemic is I know it's harder to network right now. I mean, this is networking in a lot of ways. We're getting to know each other a little bit. And it's good. But if you're starting to just talk to people just when you need a job and then ask for referral or hey, is there anything going on at your company? That's probably not a great long-term approach for things, because if you don't have a mutually beneficial relationship in terms of like meeting people, like building a real relationship, then you're not going to get as much out of your network. And that's one thing is about contributing back to your network. So Noah, your question is a job as a data analyst a good step into data science, or is it a step in the wrong direction? So Stefan Lama's reply is actually pretty good. Any first job is great experience. I would agree with that. Just about any job, at least. There are some jobs that are just truly horrible, but for the most part, you should be fine as any job. Don't worry about the title necessarily. Worry about the skills you're learning. So if the title is, data analyst, but you're doing, deep learning and really cool stuff that's really interesting, that's really transferable to another job, and you get paid really well as data analyst, then doesn't matter what your title is. So like you could have like the most awesome title at the, a good company, but you're doing really boring stuff, it's really hard to transition to a different role if you don't have the skills, because you've been spending, 3 years on a job, just looking at Excel files and, going to meetings for 8 hours a day and don't actually learn anything. Nothing wrong with like doing Excel a day. It's just in terms of like, if you want to, keep a certain skill set, it's hard if you don't actually use that skill set. So, yep. So Ilana, after 8 months, it depends on, who you ask. But also keep in mind, a lot of jobs these days are contract roles. So like, it's not uncommon anymore to have a job for 3 months, 6 months, or whatever, because the needs of a business are changing like crazy, especially now during COVID. Like, it's changing extremely quickly. So it used to be in the past, you'd stay at a job for years and years and years. And then, that'd be it. But now with contract roles and people going through layoffs all the time, it's not going to look weird to stay at a job for a short period of time. Yeah. Yeah. And Noah, are you the one still going through school? Oh, it's not you. But yeah, just get a job so you can get a job. That sounds weird, but it's true. You have to have a job to get a job in some cases, or it helps. So the first job is always the hardest to get. And that goes back to a question that Sasha was asking. You can put your resume on like different websites. Back in the day, it was like Monster. Like, if people contact you over LinkedIn, it's a short-term job. It's not the optimal job that you want to keep forever. Just interview, at least see what it is, and go from there. I should also mention right now, it's really hard to get a job. Like, it's rough out there. So I know it's hard to keep your head up, but you got to keep fighting. So, oh, Luca's here. Any other questions? So Luca gave a talk that paralleled these talks. So I'd recommend you watch this talk after you're done with me, because Luca, what's your talk on again? What was the Pacific talk?
Hi.
Hey, Luca. Welcome.
Okay. Hi, how are you?
Good. So what was your talk on today?
Building data products. We deployed a product of chart prediction to the production on the server.
So I have a question for you. So what are some methods to productionize a model? Like, just generally.
Wow, I don't know that. No, I'm joking. Depending on the structure, like the newest way that I found a few days ago is a streamlet. It is just like a few lines of code deploying the model. It has its flaws, like you can't put it in security mode because it is public. Everybody can change it. Everybody can interact. And the second one, obviously, is a Flask way, Django, and Node.js, whatever is the way of creating a RESTful API around the model itself, you can create it and deploy the model. So how to save it really depends on the model. Like, is Scikit-Learn? You talked about Scikit-Learn models. You can go for a job lib, you can go for Pickle, and then create an application around that.
So when people talk about like Docker, like what is Docker?
So I actually talked about that. I didn't use it in my, because it would be too much. But basically, there is a way to structure your application. So, for example, if I'm working on Windows and I saw your share screen is on Mac, if I'm not wrong.
Yep.
So the totally different environment. And if we want to make sure that we have the same results, the Docker is providing a virtual machine way around the application itself. So, and the second one, I deployed the model on Linux Ubuntu 20, 04 or something like that. If you have Fedora or if you have other Red Hat distribution, for example, you wouldn't be able to follow the same exact steps to deploy the model. You would need somehow to do that, or change the steps or deploy model in the different environment. So to overcome that, use Docker image and Dockerize your project.
So how'd the talk go? Just out of curiosity, because unless other people have other questions, I'm just going to chat with you.
It went well. I can't talk anymore. I'm really sore, but it went
sorry.
well. No, it's okay. A lot of talk, yeah. I didn't use Open Data Hub. I don't know what is that.
So, Stan, it goes to show that like even people that have been around in data science forever, we don't know all the tools, we don't know all the frameworks. Like I almost never use PyTorch, for example, like deep learning framework. I use TensorFlow, like it's going out of business. So like it just depends on use case, job, what you're used to, because there's so many tools and frameworks out there these days, and ways to do things, So, oh, cool! It's a container-based data science platform, open source. So
Nice.
One thing I've also noticed these days is there's a lot of different like products that are trying to like find ways to deploy models and claim that sort of like niche in the market. Or are there other people trying to take over like distributed computing? There's more than one competitor to Spark these days, and just a bunch of stuff. So that's it for questions, I think. Anyone want me to just ramble on about anything? And Luca, thank you so much for answering questions. I know you're tired. You don't have to do this,
How was your speech?
I mean, I'm still on my talk, so I would say it went okay at least, since people are still chatting here.
Let's ask people how he was.
So how'd it go? So how was this talk? Also I'd recommend like after this, when Luca's talk is available, I'd recommend actually just like looking at it, seeing what's going on, because Luca is actually an expert in deploying things, understanding how this stuff works. So he has a lot of deep knowledge and a lot of things that are actually very, very practical for jobs, and starting things himself. So I would recommend looking at his LinkedIn, see what he has, what he's done. Very impressive. So as far as like follow-up questions, you're more than welcome to message me on LinkedIn, Svetlana, and anyone really.
Yeah.
So it's, I'm always happy to chat. In general, like I'm at, I think, 18,000 connections now, so there's only so many questions I can answer at one time, but we can always chat, So yeah.
Yeah, I'm pretty much jealous about that amount of connections.
Yeah, that's because of all the teaching stuff. Like I think it was a blog. I think it was the blog that caused that one, because I used to blog all the time. So, Graham asked, were these talks going to be made available YouTube or Super Data Science? I imagine Super Data Science, Luca.
Right? I don't really know. I saw from the previous on YouTube, like previous premium talks were on YouTube. So
yeah, so eventually they'll probably be on YouTube. You can ask Diane about that, the one that just posted about the DoorDash gift cards. So I would definitely, yeah. So.
Unfortunately, I'm not from USA, so yeah, okay.
Yeah, I'm sorry. I mean, at least, yeah. Hey, but USA is having some issues sometimes, so not too bad where you are.
Yeah.
So.
Then we have very good food in Serbia, so I'm not worried about it.
So, yeah, all this is good, I think. So Graham, I would follow up with people from Super Data Science, but typically for these premium ones, they usually like wait a little bit after the talk and then they post. For the normal talks, they're usually posted pretty fast, when I remember. But yeah, and we're just chatting now.
Yeah.
So
yeah, actually that happened in my talk too. Like some guy came and we had a great chat because he just wanted to network, and that's amazing. Like because there was pretty no questions at the end, and he just came and we talked about amazing things. So.
That's good. I mean, yeah, networking is great, and also just like chatting, because it's been hours of just talking and talking. You know, I didn't get to cover everything I wanted to, though. That's the other thing I would briefly want to mention to my class. So, just as an FYI, and I'm not, I'll bring it back on, Luca. Don't close your window or anything. So I didn't cover everything I wanted to cover today. So we really stopped, you know, at bag trees / random forests, and I really put a lot of effort in some animations for some of this stuff. So, you know, if you really want to, you know, I'd advise you to look through things, you know, see what happens when you tune, you know, change the C value, accuracy, like just, you know, and there's other notebooks here about like one versus all, which I really didn't talk about much. So logistic regression is typically used for binary classification, but there's ways to make it, many different ways to make it for multi-class. So there's other things you can read about, but there's a lot of different methods that work for multiple different binary classification algorithms. So, and like how they work, why they work, and all that sort of stuff. So I recommend you spend a little more time on the notebooks if you want to look at them. If not, it's fine with me. So.
Actually, you mentioned animations, so I think you don't know. I created a library for Python called MLTutor, which allows you to, in real time, train the algorithm for any, like for Scikit-Learn or any other, and it will provide the animation on the real time training on your dataset.
Oh, so like the cost function, all that stuff.
No, really, like it will visualize data into 2D. Like for example, if it has sparse data, it will minimize to two features like X and Y, just to have you visualizing in the notebook. And for example, CNN, it will go and draw the lines in the real time, like watching the Manhattan distance, for example, between every single point. And
really?
Yeah. I will send you the link. It has about $4,000 right now in users, and basically you can, like for example, you can call how it works, and it will generate a blog inside your Jupyter notebook on how it works. And for example, you can go and interview questions. It will generate interview questions for that particular model.
Oh, that's awesome. Yeah, you gotta
It's
share that
amazing.
one. Yeah.
About Svetlana, so yeah, so you can watch my talk. We just did the whole pipeline of how to deploy the model. But yeah.
So, oh, and Luke asked, what you used to say to the model except for pickle?
Joblib.
What did you say?
Joblib. That's something that I read about a few days ago. I just found out that it is more, it is better with memory than pickle. That's all.
And especially if you have a big model, right?
Yeah, exactly.
Yeah, that's a big thing. Models aren't always so tiny anymore.
Yeah.
So.
The chatbot model can be like 700 megabytes or something like that. Great.
Yeah. So, and then Stan asked, how do you spell it? I think the thing you just said. So.
Yeah, I did. How do you spell it? I think joblib like this.
Joblib.
Yeah. You're welcome.
Thanks. I really appreciate you coming in. You know, you kept the talk going. We lasted to 3:30.
We have these chat rooms right now, I think, open for well, after party or something like that.
Mm-hmm. And it's long. And yeah. Oh, and then Graham asked me, I think those are all in your GitHub. I'll post the remaining notebooks on my GitHub because I wasn't always sure like what we get to today, but I'll post the remaining resources that aren't on there in the GitHub like after this talk or tonight or whatever in a couple hours. So yeah. So I think that's it. More questions? Any last things? Comments, questions, concern, journal happiness, and thank you for following me on Medium, Sasha. Much appreciated. And hopefully these are available on YouTube and Super Data Science and all that stuff eventually. But for now, like, awesome. Okay. And
Bye.
I'm gonna stay on until Diane comes, but.
Okay, I'm tuning up. See you guys.
Okay, bye, Luca. Thanks.
Bye.
Okay. Thank you for Luca for coming on the talk and making this talk a lot more interesting because frankly, it's, you know, it's nice to have someone that does a lot of productionized code. So, because it's not just one thing of building a model, it's also making sure it goes on the website. So if someone, you know, had the Netflix algorithm, like recommending, you know, videos and stuff, it's great having that model on your computer, but if it's not in production, no one's gonna be using that feature of Netflix, for example. So there's a lot of very, very valuable things from this talk that I recommend you look over because it's useful. Yeah. And then that's it. And everything will be on my GitHub, and feel free to connect with me on LinkedIn or Twitter if you haven't already. And that's it. And thanks for the compliments, everyone. Much appreciated. It makes it worth it. And I hope you've learned something. And I hope you spend more time with the notebooks because there's only so much I can cover in 2 hours plus a Q&A. So, you know, it's limited in some ways. And I'll post the remaining notebooks later. So I did answer some questions in the notebooks, like and added extra notebooks during the sessions.